So you should be able to look at limits of trigonometric functions using the fact that we know that the limit as x approaches 0 of sine of some argument, let's say it's a times x, all over the same thing as the argument was for the sine ax. Recall that this is equal to 1. So another way to say this, sine of theta, I'm sorry, not sine of theta, the limit as theta goes to 0 of sine of theta all over theta was 1. Okay, so limit exists. It actually is undefined there, but we're going to use that fact to find the following limits. So if we want to look at the limit as, I don't know, x approaches 0 of x squared minus x plus sine x all over 2x. So again, first thing I would do, direct substitution, but I know 0 squared minus 0 plus sine of 0 is 0. So adding and subtracting 0 is 0, all over 2 times 0 is 0. So indeterminate form. And so we want to manipulate this. And it gave us a hint, use this limit that we know to help us solve this. Well, notice that we're dividing by one term. And so we could actually break this up as a limit as x approaches 0 of x squared divided by 2x minus x divided by 2x plus sine x divided by 2x. The limit of a sum, we can take the limit of each piece and then sum them. So if we really wanted to, we could break this down as the limit as x goes to 0. As I bring it down, I'm going to rewrite it. So I'm going to reduce x squared over 2x. That reduces to x over 2 minus the limit as x goes to 0, just using my rules of limits. Well, x divided by 2x, that gives me 1/2, plus the limit as x goes to 0 of sine of x over 2x. And maybe let's manipulate that over 2x. Notice that this is the same thing as sine of x over x all times 1/2, or 1/2 can be out here. So going in and doing direct substitution now, when we go in and plug in 0 wherever we see an x, it's okay to have 0 in the numerator, as long as it's not in the denominator. So we get 0 over 2 for the first piece, minus, well, if I'm taking the limit going anywhere of a constant, it's always just that constant itself. So minus the 1/2 plus, so limit of a product, we can look at the limit of each piece. So a limit of x goes to 0 of 1/2 is 1/2 times the limit as x goes to 0 of sine x over x, which we said was 1. And so let's just reduce. So we get 0 minus the 1/2 plus 1/2. So this is equal to 0. So you should be able to use the fact that the limit as x approaches 0 of sine of x over x is 1 to manipulate trig functions to find the limit. So you should also be able to take limits so that I have trigonometric functions that we're not necessarily using that one rule. Again, you want to start with direct substitution. Basically, this is a composition of functions. I have my outer function is sine of my inner function, which is this x over 2 plus sine of x. So recall, we can look at this as the same thing as pulling the sign out. Let's look at the limit of the inner function. So the limit as x approaches pi of this argument, which was x over 2 plus sine x. And so if we go in and we do our direct substitution, and wherever we see an x, we plug in pi. And let's evaluate that. So we have sine of, so looking at this limit, well, we have pi over 2 plus sine of pi. Okay, so if you're thinking of the unit circle, remember all of our points, depending on our angle, are in the form of cosine theta, comma, sine theta. If we're thinking of pi, recall pi is right here. And so if I look at that point on that unit circle right here, my x value is -1, my y value is 0. So sine of pi is my y value, which is 0. So I have sine of pi halves plus 0 is just pi halves. Well, if you look on your unit circle and figure out pi halves, well, pi halves gets us up to the y-axis, positive. So this is an angle of pi halves. If I look at the point here, this point here is 0, 1. So my sine of pi halves is my y value of that point, which is 1. So the limit as x approaches pi of sine of that whole argument is 1. Questions on that one?